So we have here in front of us three examples of what seem like a difference of squares, and we're going to look at them one at a time. Now the first example here, I have 4x squared, which looks good, minus, which is good, 49, which is good, but the y, well, that's not a square. So using the difference of squares technique, this is not factorable. Not factorable. That's easy. Moving on for the next one, we have what looks like might possibly be a difference of squares. I mean, I have an x squared here, I have a y squared, I have a difference, but the coefficients are not perfect squares. Now we might just, give up and say, well, I can't factor this. But what you should be looking for with any type of factoring is a common factor first. 50 and 98, the most obvious number they're divisible by is 2. So let's see what happens. I divide 2 into both those coefficients. I'm left with 25 x squared minus 49 y squared. Now both of these terms, what's left inside, yeah, they're both perfect squares, and I can rewrite this expression as a difference of squares with the 2 in front. So here I get 5x, and I'm going to have minus 7y, and then I will have 5x again, and then I have plus 7y. There's your difference of squares. Remember, we got to find the common factor first. Last one. This looks a bit convoluted. You might want to think to expand this, but let's use a trick I've mentioned before. I'm going to introduce a variable. Let's call it c. I'm going to say c is x plus 2. Now why do I do that? Well, look what happens when I replace x plus 2 with c. I get c squared minus 25. Or that's the same as c squared minus 5 squared, which is a difference of squares. So I can write this as c minus 5 and then c plus 5. But what did we say c was? C is x minus 2. So I can rewrite this expression as, not x minus, but x plus 2, x plus 2 minus 5 in the first set of brackets, and then x plus 2 plus 5 in the second set of brackets, and my final answer is x minus 3, close brackets, x plus 7. And there you have your factored forms for the these three difference of squares, well, except for the first one.